Your F-150 EcoBoost has factory settings and operational defaults hard-coded into its systems that are quietly cooking your turbos, destroying your rod bearings, and guaranteeing premature engine failure before you ever hit 150,000 miles. Most owners have no idea that the truck they rely on every day is fighting against its own software. Today, I am exposing 5 factory settings and features that are damaging your F-150 without you knowing. Setting number 5 is a routine calibration choice that leaves your timing chain starving for protection on cold starts. Setting number 4 is marketed as a fuel economy savior, but it dilutes your oil and shreds your bearings from the bottom up. And setting number 1 is a factory logic override that is so deceptive that owners actually think it is a performance enhancement when it is cooking the center section of your turbos to charcoal. I have spent over 15 years tearing down failed Ford power plants, and I'm going to show you exactly what these settings are, why the factory programmed them this way, and how you override them with simple habit changes that cost you $0. Let's get into it. Setting number 5. The factory cold start, high idle, and aggressive spark retard logic. Here's what you experience every single morning. You turn the key or hit the remote start on your EcoBoost F-150, and the engine immediately roars to life, flaring up to 1,500 revolutions per minute before slowly settling down over the next 60 seconds. Ford tells you this is an emissions management feature designed to rapidly heat up the catalytic converters so the truck meets federal tailpipe standards within seconds of startup. But here's what Ford doesn't tell you about the mechanical reality under your valve covers. To force that rapid heat generation, the powertrain control module aggressively retards ignition timing, sometimes pulling ignition timing past TDC by as much as 10 to 15 degrees. That means fuel is burning while the exhaust valves are already opening, sending raw heat straight out of the combustion chamber and past your turbochargers. At the exact same time, oil pressure hasn't fully stabilized across the entire valve train because the high-viscosity oil is still sitting heavy in the pan at 20 degrees Fahrenheit. For the first 4 to 7 seconds of that high idle flare, your timing chain tensioners, which rely on hydraulic oil pressure to stay firm, are momentarily spongy. That momentary drop in hydraulic tension allows the heavy dual overhead timing chains to slap violently against the plastic guides. Multiply that unlubricated whip and slap by thousands of cold starts over 3 or 4 years, and those plastic guides start shedding fragments down into the oil pickup tube. I have personally dropped oil pans in F-150s with 90,000 miles and found the oil pickup screen choked solid with amber-colored plastic chunks stripped straight off the guides by that factory cold start strategy. When that pickup screen blocks up, oil volume drops, and your top end starts starving for lubrication at 2,000 revolutions per minute on the highway. Here's what you do instead of accepting factory destruction. Do not jump in and immediately put the truck into gear and hammer the throttle the second the high idle drops. Let the engine idle down completely on its own until the revolutions settle to their normal base idle of around 650 revolutions per minute. That extra 30 to 45 seconds gives the variable camshaft timing phasers and the chain tensioners time to fully saturate with oil pressure before any physical load is applied to the valve train. It takes $0, requires no aftermarket parts, and adds 50,000 miles to the life of your timing components. Setting 4. The factory adaptive octane mapping and low-load ignition advanced strategy. Ford markets the EcoBoost engine as a masterpiece of fuel flexibility, proudly telling you that you can run cheap 87-octane regular unleaded fuel, and the computer will automatically adjust to keep the engine running smoothly. The window sticker says regular gas is fully approved and your wallet feels lighter at the pump. But here is the hidden mechanical truth that Ford leaves out of the brochure. When you run 87-octane fuel under load in a high-compression, turbocharged environment running 15 to 20 pounds of boost, the cylinder pressures skyrocket to over 1,500 pounds per square inch. Under those extreme pressures, lower-octane fuel naturally wants to detonate uncontrollably before the spark plug even fires, a phenomenon known as pre-ignition or destructive knock. To prevent your pistons from melting into slag, the factory knock sensors pick up micro-detonations within milliseconds, and the computer instantly retards ignition timing across the board and cuts boost pressure. Ford software handles this invisibly, so you don't hear the engine pinging.
But while the computer is saving your pistons from immediate detonation, it is dumping unburned fuel past the piston rings and down into the crankcase in massive quantities. This process, known as fuel dilution, thins out your engine oil. When fuel mixes with your synthetic oil, it drops the kinematic viscosity of a 5W30 oil down to the thickness of water, sometimes measuring below a 20 weight rating within just 3,000 miles of city driving. That thinned-out oil loses its shear strength under high temperatures, leading to metal-on-metal contact on your main bearings and connecting rod journals. I have pulled rod bearings out of 3.5L EcoBoost engines running exclusively on regular 87-octane fuel that looked like they had been sanded down with 80-grit sandpaper, complete with copper backing showing through the overlay. The factory setup tells you 87-octane is fine, but the physical reality is that low-octane fuel forces the computer's safety protocols to cook your oil and starve your bottom end.
Here is what you do instead. Stop treating 87-octane as a permanent default for a forced induction engine that works for a living. If you are commuting empty, running premium 91 or 93 octane fuel completely eliminates the computer's need to retard timing and dump raw fuel into the cylinders to fight knock. If you must run 87 octane because of cost, you must cut your oil change intervals in half, changing your oil every 3,000 to 4,000 miles maximum to clear out the fuel dilution before it strips the bearings bare. You are paying for it either way. You either pay at the pump for premium fuel, or you pay a machine shop $4,000 for a bottom-end rebuild. Building on the destruction caused by factory ignition maps and cold start oil starvation, we have to look deeper into the powertrain's software logic to find the engineering choices that actively undermine your engine's durability. Setting number 3. The factory-aggressive torque management throttle closure and shift scheduling strategy. Here is what you feel happen every day. You are driving your EcoBoost F150 down the highway, or you are towing a heavy trailer up an incline, and you tip into the throttle to maintain your speed. Instead of an immediate, linear surge of power, you experience a momentary, dead hesitation. A fraction of a second where the truck feels like it hits a wall before the transmission violently downshifts and lunges forward. Ford programs this behavior directly into the powertrain control module as torque management, a feature marketed to protect the 10R80 transmission gears and axle shafts from shock loads. But here is the hidden mechanical reality of what that software routine is actually doing to your hardware. To limit torque on demand, the computer simultaneously cuts fuel injectors, retards ignition timing, and snaps the electronic throttle body butterfly valve shut while the turbochargers are actively spinning at over 100,000 revolutions per minute. When that throttle plate slams shut against a wall of pressurized air coming straight from the intercooler, it creates a massive pneumatic shock wave known as compressor surge. The compressed air has nowhere to go, so it violently reverses direction, forcing its way back through the compressor blades of the turbocharger, causing the turbine wheel to abruptly break and chatter under immense mechanical stress. Simultaneously, the rapid cycling of fuel cuts and spark dumps sends unburned hydrocarbons straight into the exhaust manifolds, superheating the catalytic substrate and shocking the wastegate linkages with erratic thermal swings. I have pulled intercooler piping off F150S with chronic torque management lag and found pools of oil and pitted compressor wheel blades from the constant flow reversal and pressure spikes. That factory software routine turns your turbos into shock absorbers for the transmission, hammering the thrust bearings every single time you modulate the pedal in traffic. Here is what you do instead to eliminate this hardware abuse. Change how you interact with the electronic throttle map by avoiding abrupt, deep stabs of the pedal that trigger panic interventions from the torque management system. Instead, apply progressive, rolling throttle inputs that allow the computer to ramp up boost smoothly without slamming the electronic throttle plate shut against peak compressor pressure. If your truck has custom tuning options available from reputable platforms that optimize shift pressure and smooth out torque reduction tables without sacrificing safety limits, it removes that violent snapping action entirely. It costs nothing in driving discipline, protects your compressor blades from fatigue, and keeps your transmission alive. Setting number 2. The factory adaptive idle speed and low-pressure oil pump displacement mapping. Here is the common scenario you deal with every time you come to a red light or pull into a parking spot after a long drive. You drop your F-150 into park or keep your foot on the brake, and the engine settles down into a very low, quiet idle, sitting right around 550 to 600 revolutions per minute. Ford programs this ultra-low idle speed directly into the computer to squeeze out fractional gains in EPA fuel economy ratings by minimizing parasitic drag from the engine accessories when the vehicle is stationary. But here's what Ford leaves out of the efficiency pitch. Modern EcoBoost engines utilize variable displacement oil pumps, designed to reduce oil pressure at low idle to save fuel. When your engine is idling at 550 revolutions per minute with a warm, thin synthetic oil, that variable displacement pump dials down its output to the bare minimum threshold, sometimes dropping oil pressure down to 12 to 15 pounds per square inch at the hot idle stage. At 15 pounds of square inch, the oil pressure is barely sufficient to maintain a hydraulic cushion inside the main bearings and the roller finger followers. If you have been driving hard on the highway, pulling heat into the block, and you immediately come to a prolonged stop, that low-pressure idle starves the highest points of your engine, specifically the camshaft journals and the hydraulic lash adjusters, of adequate volume. The oil film collapses under the heavy valve spring loads, allowing metal-on-metal microcontact that scores the cam lobes and introduces microscopic iron particles directly into your oil stream. I have measured hot oil pressure on late-model EcoBoost engines at factory idle spec and watched the mechanical gauge drop to levels that would make any old-school mechanic turn white with dread. The factory logic prioritizes a quiet, low-fuel burn idle on paper, but it does it by running your lubrication system right on the razor-thin edge of starvation. Here is what you do instead to protect your internals. When you pull to a stop after sustained highway cruising or heavy towing, do not let the engine sit baking at that ultra-low factory target idle if you can avoid it, and never let the truck idle continuously for hours on end to keep the cabin cool. If you are sitting in extended traffic or parked while waiting, occasionally giving the throttle a tiny nudge to bring the engine up to 1,000 revolutions per minute for a few seconds forces the variable displacement oil pump to upstroke, surging fresh volume and pressure through your cylinder head bearings. Pair this with strict adherence to high-quality synthetic oils that maintain their high-temperature, high-shear viscosity ratings, and you eliminate the silent bearing wear that factory eco-idling creates behind the scenes. Moving past the silent oil starvation of factory idle mapping and the shock loads of torque management software, we arrive at the absolute peak of factory deception, the setting that causes more total turbo destruction than all other operational flaws combined. Setting number 1. The factory aggressive turbo spool overboost tolerance and aggressive thermal management mapping. Here is what you experience every time you roll into the throttle to pass a semi-truck or pull a heavy grade on the highway. Your F-150 responds with an instantaneous, violent surge of acceleration, pinning you back in the seat as the boost gauge spikes well past factory nominal ratings into an aggressive overboost window. Ford markets this feature as an on-demand power reserve, a clever electronic trick that lets a small displacement V6 punch way above its weight class by temporarily stretching turbocharger boost limits to deliver effortless towing power. But here is the devastating mechanical reality that Ford's marketing department completely omits from the window sticker. To achieve that aggressive overboost without blowing the engine up immediately, the factory computer pushes the turbocharger turbine and compressor wheels dangerously close to their absolute physical limits, spinning them past 150,000 revolutions per minute while simultaneously bathing the exhaust housing in extreme thermal energy exceeding 1,700 degrees Fahrenheit. The factory thermal management software allows these extreme spikes under heavy load, but the moment you lift your foot off the accelerator or shut the truck down at your destination, that massive accumulation of heat is left trapped, with zero software mitigation for the stagnant oil sitting inside the center bearing housing. The computer is programmed to chase peak power numbers for marketing brochures and towing capacity charts, leaving the hardware to absorb the catastrophic thermal debt. When you combine that overboost-induced heat spike with an immediate key-off event, the oil inside the turbo center shaft instantly cooks into hard carbon coking, choking off the oil supply lines for every subsequent drive. I have pulled dozens of EcoBoost turbo assemblies off trucks with under 80,000 miles where the turbine shaft was literally locked solid by baked carbon, unable to spin a single millimeter by hand.
All because the factory overboost logic baked the oil deposits deeper into the journal bearings with every heavy pull. The factory setting gives you that addictive rush of passing power, but it treats your turbochargers as disposable wear items designed to survive just past the warranty period before suffering catastrophic bearing seizure. Here's what you do instead to break this cycle of destruction once and for all. You do not need to flash your computer with illegal aftermarket tunes or neuter your truck's towing capacity. You simply override the factory thermal trap with absolute discipline. Whenever you use that factory overboost power to pull a grade or pass traffic, you must mentally log that the turbochargers are operating at maximum thermal saturation. When you reach your destination, you refuse to shut the truck off instantly. You sit in park, let the engine idle for 2 to 3 full minutes, and allow the cooling system and oil pump to safely bleed off that extreme overboost heat load while fresh fluid circulates through the center housing. Let's step back and look at the bigger picture of what your F-150's factory settings are doing to your investment. Ford engineered these trucks to win spec sheet wars, hit aggressive EPA fuel economy targets, and deliver effortless power straight off the showroom floor, but they left the long-term mechanical survival entirely up to you. Every time you blindly trust a factory default, whether it is cold start timing retard, low-octane knock management, torque management throttle slamming, eco-idle oil pressure drops, or overboost thermal spikes, you are fighting a silent war against your own engine's longevity. You do not need to spend thousands of dollars on aftermarket parts, specialized tuners, or snake oil additives to fix these problems. The ultimate protection doesn't come in a bottle or a box. It comes from understanding the hidden mechanical truths behind the dashboard, refusing to let factory shortcuts dictate your maintenance habits, and taking manual control of how you drive, warm up, and cool down your truck. If you want your EcoBoost F150 to cross the 200,000-mile mark without a catastrophic teardown, stop treating it like an appliance and start treating it like the high-performance mechanical instrument it actually is. Subscribe right now, hit that notification bell so you don't miss our next deep dive into the factory settings your dealership hopes you never discover, and drop a comment letting me know which of these 5 settings surprised you the most. Take care of your truck, give it the warm-up and cool-down discipline it desperately needs, and I will see you in the next breakdown.